type of motion. Now we are moving to our next point, displacement. What is meant by displacement? It's simply, it is defined by change of an object which is occur or observed over a time interval. Simply we can say that any object changes their position from one place to the another place with or over a time interval. Simply we can consider an example. Just consider a simple example. Consider example of a car. In the car which is at a rest position in your parking. This is your parking. We can say that origin. Now we start your car and moving a forward directions at particular time, at a small time. The car changes their position from origin to point P1 at time t is equal to t1. So in this time interval from your rest to t is equal to t1, car changes their position from origin to the point P1. It's moved from origin to P1 with distance x1. Again we just move or forwarded the car in same direction for particular or some time instant t is equal to t2, which changes their position from P1 to say P2. For this point, the car changes their position from origin to P2 with distance x2. And this change observed for time t is equal to t2. So we can say that the position vector for first case, position vector OP, in that case your car changes their position from origin to point P1, which is nothing but x1 and in a second case this car is moving same direction, forwarding the same direction, changes their position from P1 to P2. So the position vector OP2, this is OP1, this is OP2, which is nothing but x2. Now here we can see that this displacement is a vector quantity, and when you say the vector quantity, you know that the vector having magnitude as well as direction. So the change of an object, the change in the position, we can see that the position x1 or x2, which is nothing but, or here the difference between P1 and P2, you can say that this is the displacement. So I can write delta x, which is a displacement, the your car or an object which changes their position from P1 to P2, which is nothing but delta x, which is equal to, we can write the change in the quantity. This delta x represented the change in the quantity, which is nothing but difference between the two positions, position P2 and position P1. This position vector OP2 is nothing but your x2 and position vector OP1, which is x1. So the difference between x2 minus x1 gives us the difference between this position, and this is nothing but the displacement of a car from point P1 to point P2. Again, this car is moving in or along, here we can say that x-axis. So the car is moving along the x direction, or along the x direction. So here this delta x is, or this difference x2 minus x1 gives us the displacement, which is nothing but the magnitude of your car which changes their position from P1 to P2, and this direction along the x component or along the x direction gives the direction of car. So the car changes their position from origin to P1, P1 to P2, having the magnitude delta x, and the direction is along the x axis. So this is the vector quantity. So delta x gives the magnitude and along the x axis is the direction. So your displacement, which defined by change of an object of that position over time interval. This difference delta x gives us the displacement vector, which is nothing but your x2 minus x1, or this delta basically we can use for the change of that quantity. So here your change, basically this position change in your position vector. So this delta x we can write as delta x into I cap. Here in this equation, this I cap represented that the car is moving along the x axis, along this x direction. So it represented your direction of a motion of that particle or of object. So this delta x, which is equal to delta x I cap. Again, this position vector P1 and P2 gives us the displacement of an object. So P1 into P2, which is equal to delta x. This P1 into P2, which is equal to delta x, gives us the displacement of an object or a car from your point P1 to P2. This quantity gives us the displacement of a car from position vector P1 to position vector P2, which is represented by your delta x, the change in the quantity, or you can hear it, that's simply explain delta x is the difference between the two distances from x2 minus x1. Now we just consider the car. In that car there is a front face, there is a back face. So in that case, now we are just considering the car as a whole point. We are not considering the front or not consider the back side. We directly consider whole car is as a point charge or point, just a point object. So in that case, how the displacement works? So again, we just consider small example from this origin. I put some distances 1, 2, 3. Now consider the car which is moving from 2 centimeter. Here this x1 car is at the distance 2 meters. The scale is in meters. Okay? So initially car is at the rest point. Now this car is moving from 2 meter to 4 meter distance. Here car is moving from x1 to x2. At x1 their position is 2 meter. At x2 their position is 4 meter, or this is t is equal to t1, this is t is equal to t2. For time, small time interval, car changes their position from 2 meter to 4 meter. So what is the displacement? Delta x, which is equal to your x2 minus x1. So you can write your x2 or x2, this is your higher side, this is your lower 2 meter distance. So you can write 2 minus x1 meter, and which is equal to x2, which is nothing but 4 meter into I cap minus 2 meter into I cap. This basically I represented their direction, which is along your x direction. So your delta x become 2 meter. Okay. So this positive value, your delta x, which gives 2 meter I cap, this positive 2 meter, your car changes their position from x1 to x2, which is 2 meter. So here we can see that this object changes their position by positive value. So this positive value gives us the car is moving along a positive or forward direction. We can say that this difference delta x, which represented the displacement, this delta x gives us the positive value, which is nothing but we can say that your object or here your car is moving in a forward direction. In the first case we see the car is moving in a forward direction or a positive direction. Now just consider the second case. If your position, your car is at the point x2, which is having 4 meter and which is moving towards the origin at point your x2 at point x1. So car is moving from x2 to x1. Your delta x, which is nothing but x2 minus x1 bar. Your x2 is nothing but 2 meter, x1 which is equal to 4. So we can write 2 meter I cap minus 4 meter I cap. Resultant delta x is equal to minus 2 meter I cap. So here you get the negative value. So what is meant by this negative value? This negative value represented, or we can say that this sign indicate that your car or your object changes their position from x2 to x1 in a reverse direction, or you can say that in a negative direction. In first case, your object or car changes their position from x1 to x2. You get the delta x is equal to plus 2 meter I cap. This positive value gives that your car is moving in a forward or in a positive direction. And here your delta x gives us the negative value minus 2m into I cap. So you can say that your car or your object changes their position over time with negative direction or reverse direction. In our first two cases, in first case we see your object, which is delta x, gives the positive value. So this positive value represented your object changes their position from one place to another place in a positive direction or a forward direction. In a second case, your object or your delta x gives the negative sign, which indicates your object changes their position in a negative direction or a reverse direction. Now we just check your third case. Just consider your object at x1, which is at 2 meter. Your object changes their position from x1 to x2, which is at 6 meter. Again, this is x2, and again your object changes their position with same distance. So object is at again original position from x1 to x2 and x2 to x1. So here your x1 is 2 cm and x2 is also 2 meter. In that case, there is a round journey or object at their original position. So your delta x, which is equal to x2 minus x1, which is equal to, we can write x2 plus minus x1. Here your x1 is 2 meter and x2, which is also 2 meter. The object at their original position. This is a round journey. So you can write delta x, which is equal to your 2 meter into I cap minus 2 meter I cap. Here your delta x gives us 0 meter I cap. So this delta represented, or this value comes out 0. So this 0 indicate your object or this object does not change their position, or we can say that this delta uses the object or displacement. In that displacement just involve their initial and final position. In our third case, your initial and final case is x1. In our first case, initial position, which is x1, and final position, which is x2. In second case, your initial position is here x1 and second end position, which is here. And in a third case, your initial position is x1. Here it is actually a round journey. So your initial as well as final position is x1. So in a displacement, the particle moving in between is a immaterial. We are not thinking or not considering this in between distances. We just consider the initial and final position of that object.